I would like to thank the organizers for letting me come speak about Cancer Computer. We're an all-volunteer social enterprise, and I'm not going to keep you for 25 minutes, not even close, because I know you've been sitting here all day, so you probably want to get going. So normally when I give this presentation, I try to convince people that computers can do things like help to cure cancer, but I think the audience here is well aware of that. We got a nice endorsement recently from Craig Stewart at University of Indiana, where we're doing some work. So let me tell you a little bit about Cancer Computer. So like I said, we're a social enterprise. We take charitable goodwill from individuals, corporations, foundations, and volunteers to provide additional computing resources for cancer researchers in Canada, the United States, and Japan recently. We help cancer researchers who may have limited funding, HPC resources, HPC expertise. Sometimes we help in terms of workflow or analytics, or we help researchers who might be waiting on institutional resources to become available. Oftentimes they can be quite lengthy, or in many cases like citizen science or people who don't qualify have no other alternative. So we've gone from an idea to processing a fair amount in 4 years. I filed for a not-for-profit in Canada in May 2015. We got a charitable registration with Canada Revenue Agency. Funny story there, it took them 2 years to figure out what we were actually doing before they could give it to us. So now we have about 10 volunteers and 2 industry advisors, one from here in Illinois, John Towns at University of Illinois. Currently we have about 660 servers representing about 12,000 cores in operation for cancer research at 10 co-location facilities. We'll hopefully have 12 by the end of the year. 3 are in US universities, like I said, University of Illinois, Indiana University, and the University of Utah. 2 in Canadian universities, Queen's and McGill. So those, they're co-located right on the institution, use most of the resources of those computers that are on their institution. Any additional work, if there's anything available, goes up on the Open Science Grid, where we support 11 projects. We also have 8 on Exceed, and anything left over that's opportunistic, we try to contribute to IBM's wonderful project, the World Community Grid, and Rosetta at Home. So here's a diagram outlining basically everything, gives an idea of our cores, and I should have actually deleted the 2 at the end that tell where we're going next. So looking forward, we're looking to become a service provider with Exceed. We want to scale up our own compute cloud into graphical instances and start offering workflow assistance and hopefully at some point analytics. We're starting to get a fair amount of donations of money, so we'll soon be able to start actually hiring staff. We're looking to Europe in 2020 and maybe Asia in 2021. I always come out begging, so typically how we are a success, we ask for everything, so we get donation of evergreen hardware, which is our big one. Oftentimes we'll get co-location companies or telcos that'll give us a rack or 2. Sometimes Amazon, Azure, other cloud providers will give us some cloud credits, and sometimes we'll get discounts from vendors on hardware. We often get funds from corporations and employee matched donations, corporate donations, employer matched, individual donations, which are becoming larger. We're now trying to build up our credibility. We have a number of large funds and foundations that are about to give us money, but they want to see us have a little more runway and start seeing some actual results and that our servers have been in support of. And then we also donate, people like to honor those who have lost to cancer, so we have some servers and clusters that are named after individuals. So that's about it. Hopefully working together we can, some of you might choose to be our partners and support our social enterprise to cure cancer. And that's about it. Thank you.
Are you also trying to create a community around the users, or are they kind of talking with each other and sort of forming a community?
Doing things like that are resource intensive, so as we start getting staff, yeah, we'll start engaging the community, but the whole idea is open science, so we're going to definitely do more engagement, and being here is part of that, so yeah.
So can you talk a bit about your computing challenges and what type of algorithms you're running?
Our particular challenges generally, like we're more high throughput computing than more high performance computing, so I guess we should be at the high throughput summit, but most of our workloads are provided or created by either the user, the institution, or like the OSG exceed. So most of that is offset. We do a lot of monitoring, so like Grafana, and we use tools like that to keep things operational. We have staff that go to data centers to keep the systems up and running, if they have to repair anything, so on and so forth. So we're basically level 1, level 2 service provider as it is, but we're hoping to scale up as we can start hiring staff, because right now we're pretty threadbare with volunteers.
Any other questions? Well, thank you.
Thank you. Thank you.